So we're on the second half of page 30. We're probably going to do page 31 in this video as well, and we're going to be looking at solving advanced square root equations. So an advanced square root equation means a square root equation has more than one square root in it. Our first step when we have these, so I see I have two square roots on this side of the equation, is we want to isolate one of the square roots with the exception of a possible constant multiple. And I'm going to talk about that later because we don't have one right here at this moment. So what I do first is I'm deciding to isolate this square root, so I'm moving the other square root over to the other side of the equation when I get to this step. So once I do that, just as if we just had one square root, I'm going to square both sides of the equation, and that will cancel this square root. Now since we have addition here, I can't distribute the square root over addition. Just like we can't, distribute the squared over addition, just like I haven't ever during the year, we've talked about why that doesn't work. So I need to write this side twice, and I'm going to have to distribute from here, like this. So I end up with 4 minus 2 times the square root of x minus 3, or plus 2 times the square root of x minus 3, another plus 2 times the square root of x minus 3. And then when I multiply a square root by itself, I just get what's in the square root. So I see now on the left side of the equation, my square root is canceled. So now it looks like I have 2 square roots, but I can combine them together. So 2 square root of x minus 3s plus another 2 square root of x minus 3s is 4 times the square root of x minus 3. So now we are on to this step. We're going to have to kind of repeat the process. So I'm moving over the x and the 1. Nicely, my 1's canceled. So on this side, I just have a 1x left. Now here's that part about the exception of a constant multiple. I normally do not leave a number in front of my square root, but if I moved it over, I'd have division, which kind of just makes the problem harder. And since this is only multiplication, when I square both sides, which is my next step to get rid of the square root, I can distribute the squared over multiplication to the two parts that are multiplied. And that makes my resulting equation easier. So 4 squared is 16. A square root squared cancels, right? So we get x minus 3. From here, we're finally down to something without square roots, so we can distribute. And then set the equation equal to 0. And we're going to factor and solve. So factors are multiples of 48 that add to negative 16, or negative 12 and negative 4. And then from there, we solve. If I check both of them, so I'm plugging my answers into the original equation. Square root of 25 minus the square root of 9 does equal 2. So this is plugging into 12. And here the square root of 9 minus the square root of 1. So 3 minus 1 is also 2. So both of our answers are good. So we're going to look at solving some of these on the next page. So here is the first one. I see already that one of my square roots is isolated, the square root of 2x minus 5. So I'm ready to go right into the squaring step. So over here, that directly cancels. On this side, we have subtraction, right? So we have to write this twice and then distribute. So this side is staying. And this side, we have 1 minus 1 square roots of x minus 3. And I don't really need the one that's going to help me with the next step to see what I need to do. And then when I multiply a square root by itself, okay, a negative times a negative is a positive, and then it's just going to become x minus 3 there. So from here, I'm going to combine like terms. I might do one last step here, but since it's the first time, I can keep this all together. So I have an x. I have a negative 2, and then I have negative 2 square roots of x minus 3. From here, we're going to now isolate that square root as much as we decide to. So I'm going to move over the x and the 2 and get x minus 3. Then over here I have negative 2 square roots of x minus 3. I notice if I divide, I'm just going to create a fraction, which is going to make stuff a little more complicated. So I'm going to square from this point since I just have multiplication on this side. So on this side, I have x minus 3 times x minus 3. Over here, I don't have addition or subtraction, so I can distribute. So I get a positive 4 times x minus 3. So hopefully we've been doing this long enough. I know it's factored now, but that's not super helpful, right? Because I don't have it set equal to 0. So on this side, I get x squared minus 3x minus 3x is minus 6x plus 9. Over here, I have 4x minus 12. I'm going to move everything over. And factor. And I get answers of 7 and 3. So from here, we know that a lot of times with these equations, we get answers that don't work. So when I look through this one, if I plug in my answers, so this is mostly stuff we can do in the calculator, but I will write this one out. So I'm plugging in the 3 to the original equation. So over here, I have the square root of 6 minus 5, so the square root of 1. Here I have 1 minus 0, and that one does work. So for my second solution, I have 2 times 7 minus 5 in this square root. And quickly I see that this one doesn't work because over here I have the square root of 9, which is 3. And over here I have 1 minus the square root of negative 4, right, which is going to be a 2i, so that is not going to be equal. So I cross up the 7, that's an extraneous solution, and my only answer is 3. So I'm going to suggest trying these on your own, and then coming back and checking. So the next one, I see I have the 2 square roots. Everything's on one side, so I'm going to choose to isolate this square root. I would say like the more complicated one is usually good to isolate. So I'm moving over both of these parts. I'm going to write the square root first, even though I didn't do that in the other step. And then now that I have a square root isolated, I'm going to square both sides. So this is canceling, so we get 2x minus 2. Over here, I need to write it twice because I have subtraction. So I have, multiplying those two parts together, I get 4 from 2 times 2, and square root of x times square root of x is x. Then I have minus 4 square roots of x, minus another 4 square roots of x, and then plus 4. And over here, this side just stays the same. So from here, combining like terms, in the front I'm going to write 4x plus 4, and then minus 8 square roots of x. And moving over to isolate my square root. And I end up with negative 2x minus 6 equals negative 8 square roots of x. Since I just have multiplication, I'm going to square at this point. So over here, 64 square root of x squared is x. And we're going to multiply out this part. So I get positive 4x squared plus 12x plus 12x plus 36 equals 64x. Then we're going to move the 64x over, so 24x minus 64x is negative 40x. And I'm going to take out a GCF first. And then factor. And solve. And it does turn out, if I plug both of these in, they do both work. So moving to the bottom of the page, we have a little bit easier equation because if all we have is square roots, like I have no other term, I can just move 1 over, and I get the square root of 4x plus 5 equals the square root of 3x minus 2. I'm going to square both sides, and nicely, both of the square roots cancel, and I just have a simple linear equation left. So I subtract the 3x, and I'm going to subtract the 5, and I get, oops, copied this wrong. Okay, subtract the 5, and I get negative 3. So just checking quickly, I'll show this one. 4 times negative 3 plus 5 minus the square root of 3 times negative 3 plus 2 equals 0. So we're going to get something kind of weird here, because I get the square root of negative 7 minus the square root of negative 7 equals 0. So this is a true statement. So even though I have i's in this equation, right, that does still work. Okay, so this is a valid answer. And the last problem, I am going to isolate one of the square roots, so I'm going to move over the square root of x, and you definitely should be trying this one on your own, just to make sure you get the idea. And then we square both sides. So here I get an x plus square root of x plus square root of x plus 1. So x minus 3 equals x plus 1 plus 2 square roots of x. And I'm going to move over my variables. And I get negative 4 equals 2 square roots of x. So because this one to me looks easier, I'm going to divide by 2. I could just go right into squaring both sides. But I think it looks easier to me to move that over. And I square both sides, and I get x equals 4. So checking my answer, right, because I know that I could get an extraneous solution. I'm going to put this over here. The square root of 4 minus 3 minus the square root of 4 equals 1. So I get 1 minus 2 equals a positive 1. So that actually doesn't work. And this equation has no solution. So that sounds kind of weird, because a lot of times we're used to getting 2 solutions and one of them doesn't work. So let's just, sometimes when I'm not sure of something and I think it's weird that something has canceled out, I just take a second to look at a graph. So hopefully the calculator opens soon. Here we go. Just get it over. So by checking the graph, what we mean is going to the very original equation and just looking at that. So if I graph the square root of x minus 3 minus the square root of x, and I graph a 1, I'm going to do a zoom 6 just so I can see where the graphs are. So right here, it looks like it's possible that the graphs intersect somewhere way out here. So what I do with my window, maybe I just missed something. They definitely don't intersect at 4, right? Because we could see that. Maybe I go to my x max to like 100. Let's just see what's happening out there. So what's happening with this graph, and we could see it with the table, is basically we're subtracting 2 numbers that are approaching each other. Like if I have the square root of 100, or this would be the square root of 97 if I plugged in the 100, minus the square root of 100, I'm getting a number that's just slightly smaller than 0, and basically this value just can't get up to 1, so there is no solution. So graphs are always a great way to kind of check, right? We can see extraneous solutions, and we can also verify that there is no solution.